Hello and welcome. I've been doing a lot of pretty dry, serious videos lately, the kind of YouTube videos your parents might approve of you watching, financial modeling, educational, whatever. As you can see from my screen, we're going to get back to something a little bit more fun today. We're going to be playing poker, or specifically trying to score poker hands. So this one is a problem from the Battle of 16 again. It's an Excel problem-solving competition, and the idea is you're given, various different hands. There's 100 of them in total, where you have you're playing Texas Holdem, so there's 5 community cards, and you've got 2-player 1 cards, 2-player 2 cards, and you've got to figure out what hand each player has. I'll talk through the rules in a little bit if you're not familiar, although not in a ton of detail, so if you don't know poker at all, then you might want to, go and look that up before you watch this. So the challenge is you have to say, which of the 10 possible hands does player 1 have, which of the 10 possible hands does player 2 have, and then which of the 2 players wins the hand, which may be because they have the higher powered hand, or it may be because they have the same type of hand, but this player wins on a tiebreaker. This was a problem that people were given 20 minutes to solve, so I'm going to try and do it in something kind of like that, which well, we'll see how I'm doing for time, but that may affect some design choices I make. But the nice thing about this problem is it's like super flexible in different ways to approach it. There's a ton of different ways you can think about it. You can think about ways that kind of just tackle, counting the different types, like how many aces, how many sevens, how many threes, or you can think about types that think about just counting the suits, or you can think like what I'm going to try and show you of something that sort of integrates them both a little bit. Just a quick aside before I jump into it. I often talk about the importance of design, and once you get more experience, it gets easier to build a good design. This is actually a case where experience kind of bit me in the ass, because a similar problem to this one was an old model-off final problem, the very, very first year they ran model-off, except instead of playing Texas Holdem, where each player has their own cards and then the sum shared, they were just playing, I guess it's 5-card stud, where each player just has their own 5 cards. So you just had to score a 5-card hand. And so, if you're just looking at 5 cards, there's some pretty neat kind of simplifications you can make. So let me just quickly show you one of what I had in mind. So this is, here's an example hand. I've already played around with it, but let me put it back to where it was. 10, 7, 3, 3, 9. So, basically if you get out the number from each one of them and then you count how many times that number occurs, so you can see, there's only 1 10, there's 1 7, there's a pair of 3s, and there's 1 9. If you sum up those 5 numbers, you get something that uniquely identifies about half of the different hands here. So in other words, this here where they add up to 7, the only way you can get that is if there's 1 pair. If you add a second pair, let's make that a 10, then you get a sum of 9. That's the only way you can get 9. If you add another 3 to make it a full house, you get 13. That's the only way you can get 13. If you take away one of the 10s and make it 3 of a kind, you get 11. That's the only way you can get 11. And lastly, if you make that one a 3, you get 17. That's the only way you can get 17. So if you're looking at just exactly 5 cards, you can identify 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, all from, basically 2 formulas, which is a pretty cool trick. But the reason I say that led me astray is because obviously that works well if you have 5 cards. But I looked at this and thought, classic mathematician's mistake. Oh, I can, reduce this to a known problem. I know how to deal with 5 cards, so, how hard can it be to first figure out what are the 21 different possible hands of 5 you can make from these 7 cards, and then the same thing for the 7 cards on the other side, and then, score each of those, which you can do it, but it's a terrible approach, especially for a 20-minute problem, to set off down the path of, trying to figure out all the 21 different ways you can make 5-card hands out of this, when, if you structure it a different way, you can do an analysis that will just say across these 7 cards, or across, 10 cards or 50 cards or 1,000 cards, how many of these combinations are ticked off and what's the best one. So that was, I didn't actually end up building it that way, but when I first looked at the problem, I thought to myself, hey, this is the way to do that. Terrible idea. So that's one case where, experience that's somewhat similar, but not quite the same, can actually end up throwing you off. Sometimes you're better off to just start from a blank slate, so to speak. Anyway, so here's my calc sheet. I'm going to, wait, first I need to make this all giant so you can read it. Sorry, select the whole thing. We'll make it 20 point. So I'm going to select the game. and I'll just put in 1, and then I'll get the cards, which will just be index on this whole set of cards. We'll get both players at the same time, comma, game number, which is C2. So that gives me the row, and then 0 for the column index, meaning take all the columns. I guess I'll just put, sorry, shouldn't have hit Control Enter, should have just hit Enter. Still getting used to dynamic arrays. Just add that and double quotes so that it doesn't show zeros here, it just shows blank. So those are my cards. These are the ones available for player 1. So they're 2 plus the community cards, and these are the ones available for player 2. They're 2 over here plus the community cards. So the first thing I'm going to do is lay out a grid of the possible cards. So I'm going to ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. And sorry, I realize as I'm doing this that I promised I was going to quickly walk through the hands. I haven't done that, so let me come back here and do that quickly. So from the top down, so best combinations at the top, weakest ones at the bottom. Royal flush is this exact set of 5 cards, 10, jack, queen, king, and ace, and all of the same suit. So just like that. A straight flush is the same thing, except it doesn't have to be those exact 5, but any 5 cards in a row. So like here, 5, 6, 7, 8, 9, and all of the same suit. And in this case, an ace can be either high, meaning it's the highest card, so 10, jack, queen, king, ace, or it can be low, meaning it's treated as a 1, so ace, 2, 3, 4, 5 is also a straight. Then 4 of a kind, so all of these, pair, 3 of a kind, 2 of a kind, the kinds you're always counting as not the suit but the other piece, so in this case you've got 4 aces. Full house is 3 of one thing, 2 of another, so 3 aces, 2 kings. Obviously you're just using one deck of cards, so 5 of a kind is not a possibility in this case. Flush is all 5 cards have the same suit, so in this case they're all clubs, but it doesn't matter what numbers are on them. Straight, just like a straight flush, except they can be different suits, so 5 cards in a row, anything from ace, 2, 3, 4, 5, all the way up to 10, jack, queen, king, ace. 3 of a kind means you have 3 of the same thing, 2 pairs, pair of aces, pair of kings, 1 pair, pair of aces, and then a high card just means if you have none of the things above, then whoever has the highest card wins. So that's the layout. Now what I'm going to do is basically set up a grid here to say which of the 52 possible cards do I have. So I grabbed that because it was the easiest place to get all the suits. Probably there's a more elegant way to extract them, like a formula, but never mind, I'm just going to do it this way. So then what I'm going to do is I'm going to say countifs. So right now I'm just going to look at player 1, so I'm going to count that. Where that is this here, ampersand this here. And I'm not putting any dollar signs on because I'm just doing it as one array formula, and there we go. And I'm just going to format this so it's going to be 0, -0, 0, so that my zeros are dashes, and it's easier to see where the ones are. So now it's very easy to see. For example, here you've got 3 3s. The reason that I've laid it out with an ace at the bottom and at the top, obviously, is so that ace can be low to complete a straight here and high to complete a straight here. The important thing, obviously, is when I'm summing the columns, I only want to count it once. So just to remind myself of that, I'm just going to turn this a more alarming shade of orange to warn me. Okay. So having done that, I've actually probably made my font a little bit too big, so let me zoom out a little bit. Having done that, I'm then going to say count by whatever I call it, type. That's just going to be the sum of these. And I'm going to do that for every row except this one, because again, if I have a pair of aces, I don't want to accidentally tell myself I have 2 pairs by seeing a pair up in this row and a pair down in the bottom row. And then I'm going to do count by suit. And that's just going to be a sum of these. And basically everything that I'm interested in is some combination of those two, except then I'm going to look at straights. And for a straight, I'm interested in any 5 of these in a row. And yeah, so let's just say, we'll start off with 5. So I'm going to say the min of these. So basically, if there's any zeros here, then you do not have a straight flush ace to 5 of clubs. But if there are no zeros, so the minimum is 1, then you've got that. And so we just copy that across and down to all the different types of straight flushes you might have, and then to get an overall straight, I'm going to say min of these. So again, if there's at least one of all of these, then I've got a straight, but if there's not, and so this is just the one where I'm summing across the whole row, so it doesn't matter what suit it is. And if there's not, I don't. So having done all that setup, now we basically just need to go and grab our list of suits and figure out if we have them. So do we have a royal flush? Well, that's very simple. That is going to be the sum of these 4 cells. So these are the 4 cells checking for a straight of a single suit ending in a high ace. So sum of these guys. And just to keep everything consistent, I'm going to make them all 1s or 0s. I'm going to say minus minus that greater than 0. Or actually, again, I have to remind myself sometimes to make things more readable for people who don't excel as much as I do. So I'm going to say if that sum is greater than 0, then 1 meaning I have a royal flush, otherwise 0 meaning I don't. Then straight flush is going to be a very similar thing, except instead of just summing one row, I'm going to be summing all of these 4 columns. So in other words, if any one of the cells in this grid ticks off, then I've got a straight flush. Then 4 of a kind, I just need to say, do I have at least one thing here that is 4? And again, I'll say if this is greater than 0, then 1, otherwise 0. I'm just going to copy this format down to the rest. And again, I did mention, the way this is set up in theory, it could account for if you had multiple decks or a greater number of cards or whatever. So just to be safe, I'm going to make this greater than or equal to 4. Because if you have more than 4 of the same thing, then you'd still count that as 4 of a kind. So then, similar thing here, I'm going to say equals if, count ifs. So I need at least one greater than or equal to 3. That has to be greater than 0. So and I need at least 2 that are greater than or equal to 2. The reason I'm not saying I need 1 3 and 1 2 is because in theory you might have, across the 7 cards, you could have 3 5s and 3 6s, in which case you'd still want to credit that as a full house because that's better than going 3 of a kind. In theory you could also have like 4 5s and 3 6s, but then you'll tick off the 4 of a kind box and then you don't want to carry on. So I want to say then count ifs this same thing is greater than or equal to 2. That has to be greater than 1. So in other words, I need at least 2 that are at least 2 pairs and at least 1 3. At least 2 or greater. You know what I mean. I think you know what I mean. I hope you know what I mean. Then a flush. Flush is right. So I need, again, I'll make it if count ifs. And again here, you might be tempted to say count the number of those that are 5, but actually it's theoretically possible that you could have 6 or even 7 of the same suit if there's a flush just in the community cards and then you add 2 more of the same suit. So we're going to say greater than or equal to 5. So if that is greater than 0, then 1, otherwise 0. Then a straight, that's just going to be if sum. So here I'm interested in the last column. So remember, I should probably label this a little more cleanly, but anyway, these are the 4 that are suit specific, and this is the one that is not suit specific. So if that sum is greater than 0, then you've got a straight, otherwise you don't. Then 3 of a kind, 2 pair, 1 pair, high card. So I'm just going to copy down from full house and adjust that. So 3 of a kind means I've got at least 1 greater than or equal to 3. And again, this would tick off if you had 4 of a kind as well, but the way we're going to set it up is we're going to check our way down. So we're not going to be interested in 3 of a kind if there's 4 of a kind. So I'll just say greater than or equal to 3. Actually, in that case, you could just say 3 as well. Then this one, you want the other side of that, which is, are there at least 2 that are at least 2? So count ifs greater than or equal to 2 has to be greater than 1. And again, in this case, you could just say equal to 2 because if at least one of them is greater, then you're going to tick off the box for a full house further up, but either way is fine. And then one pair is just the same thing, except it has to be greater than 0. And then high card, there's always a high card. And again, the logic being, you could think of it exclusively as in if all of these are 0, then 1, but it's easier to just type in a 1 because we're going to check these down as we go. So finally, I'm interested in what is player 1's hand. So let's do hand index. Copy it over to the one that's already a little wider. Let's just number these. Sequence 10, I think there are 10 different kinds, yes. So hand index, I'm going to say min ifs. So I want the smallest of these, 33, 4, for both sides, where this is 1. And then hand is just going to be index, this hand number. I guess I'll lock that in as well. Okay, so then quickly I want to reproduce all of this stuff for player 2. So I just said I was going to label all of these straight by the different suits or any. So now let's grab all of this. We'll have to be a little bit careful about exactly how we reproduce it for player 2, but it shouldn't be too hard to recycle most of what we've done. So first things first is here. We want this to point to those 7 cards. So that part's done. This all points here, so that's all still working fine. That's just all a local reference, so that's fine. Down at the bottom, that's all working fine. So then let's come down here. Are these, I made some of these absolute references to make it easier to copy the formula across. So I guess what I'm going to do is I'll just come over here, find the dollar signs, replace with nothing. So now I've removed all the absolute. So I just had absolute references to make it easier, for example, to copy the full house formula down to 3 of a kind, 2 pair, etc. But now I want to be able to copy them across to here without anything being locked in. So I'm just going to do that. And then, again, I probably should just never have locked that bit at all, but it's fine. So the min of, sorry, that bit is fine to lock. This one's the one I should not have locked, but that's fine. Where that's a 1, and then we index on that. Perfect. And then the last thing I need to figure out is who's the winner. So I'm going to say, basically we're interested in the higher up here you are, meaning the lower number this is, the better you're doing. So I'm going to say if this is less than this, then P1 wins. If this is greater than this, then P2 wins. Otherwise, it's a tie. And then I just need to make a table to run this for all 100 suits. So player 1 hand, the 3 things that I need to, for the answer are the player 1 hand, the player 2 hand, and the winner. And then I need to do this for 100 games. So I table that. My column input cell is my game number. And I hit calculate, and it's pretty much instantaneous. So then I've set it up over here so that it will score me as I go. Now the way the scoring they mentioned is done in this one is you have to get all 3 pieces for any given game right to get the score. So hopefully I'll come over here, just grab that one, put it in, and we should see, yes, I got my 4 points. So it's 4 points for level 1, 8, 12, 16. So I'll copy this down. So without doing anything to resolve ties, I can get to 860. If I just took a gamble and said, well, tie is never the right answer, someone's got to win, then I could probably get a few more points. So no more for doing P1. Oh, sorry, I gotta hit calculate because I have it on not auto-calculating data tables. So yeah, that gets you up to 940 as a kind of a cheat. But so again, under time pressure, I might just do that. But the other thing, and again, this is where the fact that it's a 20-minute exercise comes in. Oh, interesting, I have that one wrong as well. So I'll have to figure that out in a minute. But anyway, so for my ties, there are a total of just 8 of them. So under time pressure, I think I would legitimately just go through this and do them manually. So here, for example, you've got 3, 4, they've both got 5, 6, 7. This player has an 8, so P1 wins. I'm just going to highlight the ones that I'm messing around with. Okay, so they've both got 2 pairs. Let's see, aces and jacks versus aces and 8s, so player 2 wins. Here, both got straights. This one has a high straight going to the ace, so player 1 wins. Here they've both got straights, so probably the jack wins, it's player 1. And 4 more of them. They've both got 2 pairs. This one has a pair with queens, so player 1 wins. High card, this one has the higher card, so player 1 wins. They've both got flushes, so the higher card wins, that's the queen, so player 1. They've both got single pairs. This one has pocket jacks, this one has a pair of aces, so player 2 wins. Oh, it says I'm wrong in this one. Oh yeah, so interesting. I seem to be missing a straight flush here, because this is 3, 4, 5. Oh no, 7, 8. There's not a straight flush. So why isn't player 1 winning here? Okay, that might be a mistake. I think player 1 is winning here. Anyway, yeah, like I said, the fastest way is to just go through it manually, unless you absolutely need a perfect score. It says I got this one wrong as well. So let's see, pair of aces, pair of queens, so that's right. 10 jack, queen, king. That is not a straight at all. So how did I think that that was a straight? What game number? 55. Let's figure that out. Oh, shoot. Okay, so this is where you need to be a little more careful about your combinations. So I said I was being careful not to sum this one, not to sum this row up, because I didn't want it to look like an extra pair. But actually, for this formula, I did need to sum it up. So I need to copy that down and just double check that none of my formulas here go down as far as row 20. So I guess it would be T20. Let's just see, we can, what depends on that? Only this. Okay, so nothing else points to that cell, so we're good. And then I just need to do the same thing over on the other side, which is right here. So oops, sorry about that. And just again, make sure that nothing else is depending on that other than that one. It's not. So then I hit recalculate, and then it gives me that one right. This one, you know, I remember this one. I think this one might have actually been a bug in the version of it that I got. So I'm just going to, whoops, I'm just going to change that to P2, but actually P1 is the right answer there. Anyway, and that gets me the 1,000. So that's the whole thing out. Hope you enjoyed that. This kind of stuff is a little bit more fun for me than you know, trudging through debt modeling and that kind of thing. But you know, like I think I've mentioned before, I'm going to try and do a somewhat healthy balance of both, some vaguely educational stuff and some like this that's just fun for me to do. I think that's all I've got for today. Thank you for joining me.